Hello, let's try to solve a Leetcode problem today. Today we are going to solve number 41, first missing positive. So it's a hard problem, and even we did it many times, it's really easy to make mistakes because if we did it many times, we basically know how to solve it. But there are still some tricks we may forget each time we did it. So we are giving an unsorted integer array nums, and for example, this is 1, 2, 0. Return the smallest missing positive integer. So what is the smallest missing positive integer? For this example, this is 3 because there's only 1 and 2. Yeah, so 0 doesn't matter, so 3 is missing. So we're gonna return 3. For the second example, we don't have number 2, so we're gonna return number 2. For the third example, we don't have number 1, so 1 is the smallest. Yeah, because we always return the smallest integer, 1, so we just return 1. But there are some conditions we need to confirm. Yeah, we must implement an algorithm that runs in on time and uses O1 auxiliary space. It means we must do it in place. We cannot use any other memories like set. Yeah, and we must run it in on time. This means we cannot use the sort the nums and then find it. We have to use it in place. So we have to use a hash table, but we cannot define take memory of the hash table. We have to use the index of the array nums. Yeah. Now let me go to the white label first to explain it, and then go to the code editor to finish the coding. Yeah. So here, let me give you an example. For example, we have a number like 1, 2, and 0 inside of the array. What we should consider is, how many positive integers this can hold. For example, if the situation is like 1, 2, 3, we don't have, we hold all of them, 1, 2, 3. What is missing? The missing positive is 4. Similarly, for the first array 1, 2, 0, the first missing is 3. Because we have 1 and 2, 3 is missing. So what is the range for the positive integers given an array? The length of the array is L. Because later on I will use L as my variable. So here I will use L as the length of the array. If we have a length of an array and it is L, so what is the range of the positive integers it can hold? Of course, it is like 1, 2. It can be a 1, it can be 2, it can be 3, right? It also can be 4. Right. So if we are giving a array, the length of the array is 3. Like that. The missing positive integer can be 1, 2, 3, and 4. So this example is 4, and this example is 3. What about 1? We can directly have a 2, 3, or 2. So the missing positive is 1. What about the 2? We can have 1, 1, and 3. We can put as many examples as possible. We know that the missing positive is 2. So the range is 1, 2, 3, and 4. So that is for sure. But for this number 4, it means if we didn't find any, so for example, we have all the values like 1, 2, 3. We didn't find any negative because later on we will use negative values to check if we find an index or not. If we didn't find any negative values, here I use minus sign. It means we're gonna return the length of the array plus 1. We will gonna return this 4. But if we find, it must be 1, 2, and 3. So for this situation, basically we're gonna use 3 loops. So the first loop is turn the negative and 0 to infinite. Here I use infinite because the infinite can avoid many testing cases. And if we don't use this infinite, we're gonna make a lot of mistakes. For example, the first loop, we're gonna turn this 1 to 0. We're gonna check if this number is more than the length of the ring L, we're gonna give it an infinite. If it is a 0, we're gonna give it an infinite. So the first loop, we're gonna flip the 0 and negative to infinite. So for 1, it is still in rings, it is 1. For number 2, it is still in rings because it is less than L and more than it's more than 0 and less than and equal to L. So 2 is still there. But for this 0, we're gonna give it an infinite because this 0 doesn't matter because our range is 1, 2, 3. We're basically gonna find a value between 1, 2, and 3. So the 0 doesn't matter, so we give it an infinite. Yeah, or you can give this 0 L plus 1. It's also the same, but for me I will use infinite because for my second loop I will still use the infinite. So what about the second loop? So the first loop is basically flip the 0 and 0 and if some numbers out of the range to infinite. If there's a number like 4, yeah, 4 is still okay. But if if a number is 4, like if a number is 4, we know 3 is missing. So we'll give this number to infinite because it doesn't matter. We're gonna only conserve 1, 2, and 3. Yeah. So this is the first step. The second step is we're gonna turn the positive to negative. Yeah. So how we are going to do this is the hash table basically. For array, we're gonna use the hash table index. Here is 0, like 0 index 1 and 2. But here we're gonna use this 0 to represent 1, 1 represent 2, and 2 represent 3. Because it is straightforward, we can use this index to represent any numbers like 2, 3, 4, or any others. But here we need 1, 2, 3. Why? Because we're only gonna to find a value between 1, 2, and 3. So here we're going to use this index as 1, 2, and 3. For example, the first number, this is 1. How we are going to do it? Yeah, here is 1, 2, and infinite. We're going to use this 1 here at index 0. Yeah, but we're going to use this 1 minus this number 1 minus 1. Minus 1 is 0. Yeah, because we don't use this to represent because it's not enough. We have to start from the 0 to represent 1. So this 1 will minus 1. We got a 0. So at this place we're gonna give a minus. Yeah, because the minus is something we find. Yeah, for example, this is a 2. 2 minus 1, it is still 1. It is at index 1, so we give it a minus. But what about the infinite? So the infinite doesn't matter because we don't consider any infinite. Yeah. Now let's go to the third loop. We're gonna finish our all our loops to solving the problem. Basically, we're gonna need 3 loops. So the third loop we're gonna find. If we find a number that is positive, it means we find. So what is positive? The first one not, the second one not. What about the third one? Yeah, infinite is positive. It means we find the number. What is the number? It is 3. But what if we didn't find? It is still a negative value. It means we're gonna return 4. It's like this case. We're gonna return L plus 1. We're gonna return 4. So why it always works? Because by approaching these 3 loops, we're gonna find which value is the smallest. Yeah. So the first step, we're gonna find any value that is 0 or more than the length of L. Yeah, we are sure that numbers doesn't matter because we're gonna find some range between like 1, 2, 3. So we give it an infinite. And the second loop, we're gonna take the numbers to negative, but the infinite is gonna still be here. The third step, we're just gonna find this positive infinite. Yeah. Now let me go to the code editor to finish the coding. Yeah, if we find any problem, I will go to the whiteboard to explain more. Yeah, so basically I'm gonna define L. L is the length of nums. And we're gonna use 3 loops. The first loop is a flip, basically flip to infinite. Yeah, so for I n in enumerate nums, if this number n is less than or equal to 0, it is a negative number. Yeah, or n is bigger than L. So here the first step is flip negative to negative and 0 to inf. Yeah, so if it is 0 or negative, or it is out of the range, yeah, or it is out of the range, so we just need to flip the nums I. So the nums I should times nums I should to inf. Yeah, so the first step is set negative and 0 or out of range. Yeah, let's make it set out of range. So that is means not into 1, 2, and 3, not between 1, 2, and 3. Set out of range to infinite. And the second step is to set negative, set positive to negative. Yeah, we have to perform such steps, otherwise basically we cannot solve the problem. So it is like a template or something, because we have to use the index, and there are a few little problems we need to use the index as a hash table to solve the problem. So the second step is set the positive to negative. It will still be the same for I in enumerate nums. The first step is we're gonna set this n to have its absolute value, because if we didn't do it, there's a minus value for each of the step, because here it seems okay, everything is positive, but here if something happened for the following loop, it may produce negative values. This is why we have to set the n to always be positive. Yeah, and as I said, the nums n should minus 1. This is for here. So this is for here, because we want to, if we find a number, this number minus 1, it means at this position, at the first index position, this number at this position, we will set it to negative. Yeah. So how to set it to negative? It is a positive, it doesn't matter, but if it is a negative, we're gonna set it. Yeah, so if this is a positive value, the absolute of it, and we're gonna have a minus, it will be, so it will be a negative value, because this absolute will always be positive. Yeah, so this means if this number is a positive value, it will be set to negative, because this is minus, right? So if this number is a minus value, yeah, do you think that is possible? Yeah, if this is a minus value, so this will still be minus, so everything is safe, because minus value, it means that value is important. It is yeah, some value we find in place of the array, so it is still okay. Yeah, so we're gonna use this syntax to check all the conditions. Yeah, and the third step is to find the result. still it will be the same for in enumerate nums. So if we find the value, if this n is a positive value more than 0, we're gonna return I plus 1. If we didn't find, we're gonna return L plus 1. As I explained the situation, if it is 1, 2, 3, we're gonna return 4 here. Yeah. Now let's just have a check if we didn't if we made any mistakes or not. Yeah, so here is the set out of the range. Here is the set positive and positive to negative. Yeah, this is nums n minus 1. This is minus n minus 1. Yeah, so here is a condition. We have to check this infinite because for the first step, we have set some value to infinite. We have to check the infinite condition. So if n not equal to infinite, we can set it, yeah, to the negative value. If n is infinite, it's not possible because infinite minus 1, it will out of the index will out of the range. Yeah. Now let me run it to check if everything is okay. Yeah, it seems everything is okay. Now let me submit it to check if it can pass all the testing cases. Yes, as you can see, it passed all the testing cases and it's pretty fast. The only difference for my solution is that I use infinite. And why I use infinite is because I think infinite is easy to solve such problems. Of course, I can use L plus 1, but it's basically the same. And also for here, this is very important. We have to set this one. Otherwise, between these loops, it will set some numbers to a negative number. And for this negative number, you will make mistakes because it will out of the range for such nums. So here we have to always set this n to a positive first. Yeah, and if this is not equal to the infinite is set by the first loop. So we're gonna set it, we're gonna set this number to a minus value. Yeah. If it is a minus, it will still be a negative value. So if it is a positive, definitely we'll set it a negative value. And for the final step, we're going to find if there's still some opportunity, we have a positive value. If we didn't have the positive value, we're going to return the length of the ring plus 1. Now let's analyze the time complexity for this method. So there are basically 3 steps, and each of them